Hi there, folks. Today we're looking at slopes of lines, finding the slopes of lines using points, graphs, tables, that kind of thing, and then some of the relationships between different types of lines and their slopes. So, just a reminder for slope, the slope of a line has this formula. It's y sub 2 minus y sub 1, the second y value minus the first y value, over x sub 2 minus x sub 1, the second x value minus the first x value. That's like the official formula that you can plug into. I prefer this second model, which is change in y over change in x. It yields the same thing, but it converts that subtraction to a more of a mental process. And it's okay for you to go and use the formula. That is fine. All right, I'm typically going to use change in y over change in x. It's a higher level way of thinking about it, so it requires a little more thought processing, but it saves you in terms of the work. Okay, and then the last one, rise over run, that's the one that we kind of look at when we're looking at the graph of this thing. So visually, we see how far up, how far over. It's that pattern that we've been looking at when you graph lines using points. To get extra points, we followed the visual pattern that we saw. That's just rise over run. That's our slope in that kind of visual format. For example, if I look at something like this guy, this one I'm going to use the actual formula for, so I'm going to use that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The next one, maybe I'll do the change in y over change in x. So if you prefer using that formula, that's okay. So I'm going to do the slope. So the second y value is a 4, minus the first y value is a negative 5. And again, keep in mind that there's a minus sign built into the formula. It's like an opposite sign, all right? So the opposite of a negative 5, this ends up being 4 plus 5. When it's all said and done. So keep that kind of stuff in mind. You know, when you see minus signs built in to the formula, don't drop those. It means we're going to end up having the opposite of the thing we plug in, which we end up having here. And then second x value minus the first x value. And once again, that's the same thing as saying adding a negative. All right, it's the opposite of that 4 is a negative 4. So that's a negative 6. So it's 9 over negative 6. And then I don't typically write the negative with the denominator. Also, I need to reduce this, so I'm going to do a negative 3/2. Okay? If I look at the next one, I'm going to do the same kind of thing, but this time, instead of using that kind of long drawn-out formula, I'm going to use the change in y over change in x. And again, it's the same thing. It's just going to convert that subtraction to a mental process. So when I do change in y over change in x, I just go from one point to the next. I look at the first point and say, hey, the y value is a 4. Then I look at the next point and say, oh, the y value is a negative 6. So kind of think about it on a number line. All right, the change in y, how do I get from a positive 4 to a negative 6? Well, I have to move on the number line. I have to move down. And I have to move down how many units? Think about where 4 is. Think about where negative 6 is. I have to go down 10 units. And really, that's the same thing as doing negative 6 minus 4, negative 10. All right, but we're converting it to a mental process. And the fact of the matter is, that's how you should subtract positive and negative numbers anyway. Think about it on a number line and say, what's the distance? Difference and distance tend to mean the same thing mathematically, all right? And then the negative 1 to 0, well, it went up. To get from negative 1 to 0, it has to go up 1 unit. So that's negative 10 over 1, which is negative 10, okay? And think about it from the previous one. Like if I went from a negative 5 to a positive 4, that's up 9. Well, look right here. Positive 9. To get from a 4 to a negative 2, that's down 6 units. There's a negative 6. So we can kind of cut out that subtraction, convert it to a mental process. All right, that's change in y over change in x. If I look at something like these guys, for these ones, I'm going to find the slope using rise over run. So I'm going to start with A. So if I look at A, the slope here, I just find points that are on this graph, like this point or this point. All right. Or this point, and I just look for the pattern and say, what's the pattern to get from one point to the next? Well, if I look at the pattern, it's up 1 over 2, up 1 over 2, up 1 over 2. I just write that as a fraction. Up 1 over 2. It's rise over run. I put how far up do I have to go over how far over do I have to go, and that's it. If I look at B, B is interesting because, well, I don't have to go up at all, right? I'm just going over. So the question is, in terms of the pattern visually, how far up do I have to go? The answer is 0. I go up 0, and then I go over however many I want. Maybe I go over 1 each time. Well, 0 divided by 1 is a 0. And that's something significant. Remember, horizontal lines have a slope of 0, and that's important. And hopefully that's jogging your memory in terms of vertical lines. We'll get to that one in a moment. If I look at C, again, I look at the slope by looking at the points that this thing goes through and identifying the pattern that I see. So as I look at the pattern to get from one point to the next, it's down 2 over 1, down 2 over 1. So for my slope, it was down 2, so that's negative 2, over 1, which is just a negative 2. And then the last one, D here, a vertical line this time. And maybe you remember vertical line, you can go right to the answer. But if not, think about it as right over to run. Let me look through for a couple points here. Yep, here's the pattern. The pattern is, well, I don't go over at all, right? So I go over 0, but I go down, well, whatever I want, or up whatever I want, depending on which way you want to count this thing. So maybe I'm going up 1 and over 0 each time, right? Or down 1 over 0 each time. Either way, I'm dividing by 0, and dividing by 0 is impossible. We say that's undefined. And so if you remember those special cases of, a horizontal line is a slope of 0, a vertical line is a slope that's undefined, because remember, slope also talks about the steepness of this thing. Slope is measuring how steep it is, and so if it has no steepness, well, the steepness is 0. But if it's infinitely steep, like a vertical line, we say the steepness is undefined, okay? Like a parked car. The velocity is 0. It's not moving, all right? A car that's going so fast that it goes back in time, how can you even measure the speed? Because it just jumped through time. You can't. It's undefined, all right? And so it's the same kind of situation here. It's almost measuring the steepness or the angle. The other thing to note here is, remember, positive slopes trend uphill like A, and negative slopes trend downhill like C. And the other thing that's significant there is the negative value doesn't affect the steepness. It only affects the direction. So if you looked at a line that had a slope of positive 2 compared with this guy, each of those lines has the exact same steepness. The negative versus positive just tells you which direction that steepness is gonna go off in terms of the direction, okay? So please keep that kind of stuff in mind. We want to have that kind of holistic view of these things, but we also want to know the nitty-gritty. The nitty-gritty is, the slope of this one is 1/2, the slope of this one is negative 2. But understanding that positive is uphill, negative is downhill, and that the steepness is what this thing is determining. Negative doesn't affect how steep it is, it only affects the direction, all right? If I look at something like this guy, the table shows the time and cost of renting a paddle boat. Find the rate of change in the cost with respect to time. And that term rate of change, if you don't remember, rate of change is the same thing as the slope, all right? But rate of change is kind of putting the slope in context. See, slope is how we refer to it in just algebra when we're looking at lines and looking at the pattern of the line and how do we get from one point to the next. But rate of change is when we give context to that slope. So something like this guy, this is a table of values. Think about it in change in y over change in x. Like if this was our x values and this was our y values, input and output, right? It just happens to be time and cost, t and c this time. So input, output, look at the change in x. It's going up by 2 each time, right? And now look at the change in y. Y is going up by 7 each time. All right, so if I kind of think of this like slope, the slope would be change in y, which is 7, over change in x, which is 2. And when I do that, in algebra, we would just leave it as 7 over 2, right? But this is in context. We got to think about it in terms of the context. In context, we would want to divide this and say, the slope is 3.5. And why would we want to write it as 3.5? Think about what that represents. That's showing us the cost per hour. It's $3.50 per hour. Okay? And that's important. We can't just lock slope into this algebra thing that we use. The second you see slope in science, we're going to have to put it in context and figure out what that represents. All right? In science, if you're graphing time and distance, your slope isn't just slope, it's rate of change. It's describing the velocity when we start to look at that. So we want to put it in context, okay? That's the only difference between slope and rate of change. Rate of change is slope when it has context, okay? Let's talk about parallel and perpendicular lines. Parallel lines are coplanar lines that never intersect. For our purposes, all of our lines will be coplanar, so you can kind of ignore that, but that's something that will come up when you get to geometry, so I just throw it out there now. All right, so lines that never intersect. Parallel lines, we use this little symbol, a little set of parallel lines. And parallel lines have the same slope. So algebraically, their slopes are the same. They have the same steepness, all right? Perpendicular lines are lines that intersect at a 90-degree angle. I missed my little degree symbol there. There we go. At a 90-degree angle. And perpendicular lines' slopes are opposite reciprocals, okay? So they're opposite reciprocals. Here's the symbol for perpendicular lines, like a little set of perpendicular lines. And we do it that way as opposed to the other way. Like if I did it like this, it would just be a capital T, and that would be confusing, all right? So parallel lines, the little set of parallel lines, perpendicular lines, the symbol's a little set of perpendicular lines. But opposite reciprocal, opposite means we change the sign, and reciprocal means we flip the fraction, all right? So make sure you do those two things. Students tend to do one of the two and not do each, all right? Parallel lines, slopes are the same. Perpendicular lines, opposite reciprocals. For example, find the slope of the line, then state the slope of the line parallel and the slope of the line perpendicular. And I'm going to do the change in y over change in x because I like that, and I would love to convert all of you to that method because it's easier. We want to convert to a mental process. So for the slope of this one, I'm going to find the slope and then the parallel line and then the perpendicular line. So slope, change in y over change in x. Look at the y values. Here it was a -3, now it's a +7. Think about the number line. How do I get from -3 to +7? I have to count up, and I have to count up how many? So change in y was up 10. To get from -3 to +7, I got to count up 10, all right? And again, if you haven't realized it by now, that's how subtraction with negatives works. 7 minus a -3 is a 10, all right? If I look at the next one, for the change in x here, it was a 2, now it's a -4. Well, to go from 2 to -4 on a number line, I have to count down, and I have to count down how many? Well, it's down 6. So -6. And now I just reduce this thing. So I'm going to say, oh, positive divided by negative is a negative. Reduce the fraction. That's a 5/3. Okay? But now the slope of the parallel line. See, now I want to find the slope of the parallel line. I'm just going to use a little subscript with a little parallel lines here. It's a nice way to denote it. All right? So the slope of the parallel line, well, it's going to be the same. So if my line had so if the original slope was a -5/3, parallel is also going to be a -5/3. Okay? And now the perpendicular line, again, I'm going to use this little perpendicular symbol as a subscript. So slope of perpendicular, opposite reciprocal, change the sign and flip it. So instead of instead of -5/3, I'm going to make it +3/5. I change the sign and flip it. Okay? Slope of the line, slope of the parallel line, slope of the perpendicular line. All right? If I look at this one, same kind of thing. Ready? Let's find the slope. Change in y over change in x. Y was a 1, now it's a 4. How has y changed? Well, think about it on a number line. To get from 1 to 4, I have to go up 3 units, so +3. To get from 0 to -2, change in x. To get from 0 to -2, I have to count down 2 units, so -2. And of course, I wouldn't write it like that. I'd write it as something like -3/2. All right, put the negative with the numerator or stick it out front. We don't typically write it with the denominator. And now let's talk about the parallel line. Well, the parallel line has to have the same slope, so it's also -3/2. And then the perpendicular line is going to be opposite reciprocal. So instead of -3/2, it's going to be +2/3. I change the sign and flip it. If I look at the next one, same kind of thing. Change in y over change in x. Y was a 2, now it's a -8. Think about it on another line. I have to go down 10 units, so -10. X was a 5, now it's a 5. Well, think about it on another number line. How far do I have to count to get from 5 to 5? Well, 0. I don't count any. Okay? Well, what is -10 divided by 0? Well, that's undefined. Okay? But now here's the thing, the parallel line, well, the parallel line has to have the same slope. So yeah, I guess that's also going to be undefined. It's got to be the same. But now what about the slope of the perpendicular line? And see, there's two ways to do this. I could go back to a time before undefined. See, it's hard for me to flip undefined and change the sign. Oh, it's -1 over, it's -1 over undefined, Mr. Jansen. No good, okay? Go back to a time when you had numbers right here. Look at this step and say, okay, change the sign and flip it. Now it's going to be +0/10, which gives me a 0. Or think of it more holistically. Undefined means I have a vertical line. So to be perpendicular to a vertical line, I need a Horizontal line. What's the slope of a horizontal line? 0. Okay? And so don't always be locked into thinking about what's the exact algebraic number method for doing things. Take a step back and think about the concept, okay? All right, vertical line, undefined. Horizontal line, 0, okay? If I look at something like this guy again, let's find the slope. And so to find the slope, I just need points that this thing goes through. It looks like this, so I'm identifying some. So I look at the pattern, rise over run. It goes up 1 over 2, up 1 over 2. So the slope is up 1 over 2. It's a slope of 1/2. Talk about the slope of the parallel line. Parallel line has to be the same. It also has to be a 1/2. And then the perpendicular line, the slope has to be the opposite reciprocal. So change the sign and flip it. So instead of a positive 1 over 2, it's a negative 2 over 1, which of course is just a negative 2. Okay? And visually, you could graph, start up at a different point and graph a slope of 1/2. Yeah, look at that. And you see they each have a slope of 1/2. They each have the same pattern, and they're parallel, okay? They run next to each other. If you were to do a slope of negative 2, just grab any one of these points. I'll start with this one. Down 2 over 1. If I kind of create that pattern, yeah, look at it. See how they're perpendicular? And so just giving you that visual perspective of this thing, okay?